Imagine a world where the invisible becomes visible, where the very fabric of reality is laid bare before our eyes. This is the promise of understanding spacetime, a concept that merges space and time into one unified entity. It forms a four-dimensional realm, where the familiar three dimensions of space length, width and height are joined by the mysterious dimension of time. Spacetime is not a passive backdrop for the universe's events. It is an active participant. It is a dynamic stage that twists, stretches, and curves in response to the presence of matter and energy. Picture it as a vast cosmic trampoline, where the fabric of existence itself is woven. Just as a bowling ball placed on a trampoline creates a dip, massive objects in space warp the fabric of spacetime around them. This warping the subtle curvature of spacetime holds the key to understanding one of the most fundamental forces in the universe, gravity. Now, think of our sun, a blazing sphere of plasma at the center of our solar system. It doesn't just radiate light and heat, it also warps spacetime, creating a cosmic well. When you roll a marble near a well, it circles around, drawn by the curvature. This is a simplified way of visualizing how planets orbit stars. They are not tethered to the star by some invisible string, but are instead following the curves in spacetime created by the star's mass. This warping of spacetime occurs with everything that has mass, from the tiniest grain of sand to the most massive black hole. It is this distortion that gives rise to the force we experience as gravity. For centuries, gravity was a mystery. Isaac Newton described its effects, but he couldn't explain its cause. It wasn't until Albert Einstein developed his theory of general relativity that we began to understand gravity's true nature. Einstein's revolutionary insight was that gravity isn't a force acting at a distance, as Newton proposed. Instead, gravity is the result of the curvature of spacetime. Objects don't fall toward each other, they simply follow the contours of the warped spacetime around them. If you roll a marble across a flat trampoline, it travels in a straight line. But if the trampoline is warped, the marble's path curves as it follows the fabric's contours. This is gravity in action, a cosmic dance dictated by the curvature of spacetime. Now, let's explore the extreme. Imagine an object so massive and dense that it warps spacetime to an unimaginable degree. This is a black hole, a region of spacetime where gravity is so intense that nothing, not even light, can escape its pull. At the center of a black hole lies a point of infinite density, called a singularity, where the laws of physics as we know them break down. Spacetime itself becomes infinitely curved, consumed by the singularity's insatiable gravitational hunger. Black holes are some of the most enigmatic objects in the universe, cosmic monsters that warp the fabric of reality, pushing our understanding of spacetime to its limits. If spacetime is a fabric, what happens when it's disturbed? Just as a stone creates ripples in a pond, violent cosmic events can create ripples in spacetime known as gravitational waves, predicted by Einstein's theory of general relativity. These waves travel at the speed of light, carrying information about the events that cause them. Imagine being able to listen to the universe, detecting the echoes of black hole collisions, or the birth pangs of the cosmos itself. This is the promise of gravitational wave astronomy, a new way to explore the universe, offering a means to study events and objects that were once invisible to us. By studying these ripples in spacetime, we can begin to unravel some of the deepest mysteries of the cosmos.